So good evening, everyone. Welcome to the Bayley Observatory. My name is David Marshall. I am the president of the Barbados Astronomical Society, and it is my distinct pleasure to welcome all of you to this evening's little session for just especially a few guys. How many of you have been to the observatory before? Not a soul?
First for me.
First, okay. Okay, yeah, fair enough. All right, so it's time to welcome you for the first time, and then of course I hope that you will be visiting us often. So one thing about the sky, there's always something happening, lots of things to see, and it changes during the course of the year. The set of stars and objects you'll see in the sky tonight will not be there, say, like 3 months' time. You have a whole fresh set of stars and constellations and planets and everything. So I encourage you to enjoy this visit, but of course, come again soon. Next 3 months or so, yeah. Alright, so this evening's presentation is entitled A Journey into Space. So we're going to take you from Earth through the solar system and out into the vast reaches of space. So, ready? Let's begin. So this is our home, planet Earth. Now there's a question on the screen. What makes Earth special? Look at it. Okay. People. That's actually a very good answer. People. What else?
The water.
Water, yes. Mm-hmm. Anything else?
Our countries.
Countries, okay, yeah.
Nature.
Nature, okay, good.
Snow.
Snow, okay, good. Anyone else with any other answer?
Stardust.
Okay, tornadoes, let's go.
Me.
Sure.
Me.
People. Alright, so water and the air we breathe, well, water is required, as far as we know, it's required for life, period. Also the air we breathe, without it, we will not survive and we will not get the weather conditions we mentioned, tornadoes, floods, etc. The planet itself is neither too hot or too cold. You'll see some examples of planets where it is really, really hot and others where it's really, really cold. Of course, life, people, animals, plants,
Yeah.
all life that we know of exists only on this one planet, Earth. And we're about to take a little adventure. Right? We're going to leave Earth for a bit and go and explore some other places, and we'll learn many things along the way. So much. You take off in our little spaceship there, and we will visit our closest celestial neighbor. Who can tell me what that is?
The moon.
The moon, very good. So, we're going to zoom in a bit on the moon. We'll learn it's roughly a quarter of the size of Earth. So it's relatively small. Well, it's 384,400 kilometers away. Some of you would have seen it just now before you came inside. So you're looking at something that's pretty far away. It's very dry, very different to Earth. There's no water, no air. And we see it circle the Earth every 27 days. And when it does so, we note that, I'm going to show you what that actually looks like. Because as it is orbiting Earth, as it's circling Earth, Earth is rotating. And like I said, the moon orbits Earth once every 27 days. So Earth will rotate 27 times before the moon gets back to its original location. And it looks sort of like this. So the days are passing by quickly on Earth. The moon is taking its cool time. And as it's doing so, you'll notice that, watch this blue line. Notice how it's always pointing towards Earth? Right, so that's the face of the moon that we always see. It's a sphere just like Earth, it's circular just like Earth, but it's only that one side of the moon that we see, because as it is orbiting Earth, it's turning, but it's turning at the same rate that it's orbiting, and that is why only that one face of the moon we always see. Yeah. And what else do we notice as the moon orbits the Earth? Good. This is a general question. Yes, go ahead.
That line is going way around.
Okay, well, yeah, that's we get to the diagram. But what do we notice that changes about the moon every day?
The color?
Well, no, the color doesn't really change. Sometimes it goes into a half, and that is taking us directly where we want to go. It goes through phases.
Yeah,
You see the phases of the moon, and they're listed here. So right now the moon is in this phase. It's not quite full moon. See this waxing gibbous phase? On Monday evening, the moon will be full. Right? And once it goes from the waxing gibbous that you're seeing here, 2 days time will be full, and then it'll go through the waning gibbous phase, and then third quarter, and then waning crescent, and then new moon, where you don't see the moon at all.
Back over.
Right, so it's that the shadow side of the moon that faces us would be in the moon's shadow. Right, so the shadow side is what it would be. And then the cycle repeats itself. And that's an easy thing for you when it comes to learning what to do. Observe the moon every evening. You have to actually wait for it to rise like 50 minutes later every evening. So the moon rises 50 minutes later every evening. Question? When is it going to happen? Oh, well, it's just a matter of, let me see here. If we go back one slide. Because if you pick a location on Earth, imagine you're observing the moon. If we're here, and we're looking at the moon, notice you're seeing much of the face of the moon is fully illuminated, but you got a bit of a dark part here. This is actually equivalent to the waning gibbous phase. And I can show you that as the moon continues in its orbit, so I'll actually stop it right around, come on, okay, fine. Right around there. Because if you're on the moon, if you're on Earth and you're looking at the moon, roughly one half, a little less than a half of the moon's phase will be illuminated. And that is actually the half phase that you were talking about earlier. Everyone's with me? I mean, yes, you're sure? Good. All right. Because this is the reason you see those phases. Is that the moon orbits Earth? Yes, the portion of the face of the moon that is lit by sunlight changes. So it's either fully illuminated, partially illuminated, or not at all. As we said, when the moon's face is not illuminated, when it's in darkness, which phase that is? New moon, very good. All right, rolling it. Yes. So, go on here. We're going to leave moon now and go and visit. What's the question?
That's probably not. Will be next up in the moon will be Venus.
Oh, don't guess. I will tell you exactly where we're going, but then along the way, keep track of where we're going, right? The next diagram is going to be very important because you're going to look at our celestial neighborhood. Now, the moon is our closest neighbor, but our celestial neighborhood comprises of a whole set of planets and a whole set of objects, right? Remember this order here. This is the order of the planets with an increasing distance from the sun. Okay, so we got Mercury, Venus, Earth, Mars. You have your asteroid belt. Jupiter, Saturn, Uranus, Neptune. And then the dwarf planets, Pluto, Makemake, Earth, and then the Kuiper belt objects. We'll go through each one as necessary, give you some important details. You don't have to remember everything, but the important things. Sorry? Where's the moon? The moon is right there, right next to Earth. We are going to leave this little body here. Yes, I told you it's small. It's relative to the Earth. It's relatively small. Quarter of Earth's size.
Where's Pluto? Far away from the rest of the planets.
Well, that is just how the solar system was formed. It just so happens that it is far away, and it's not classified as a full planet. It's a dwarf planet, just like Makemake here and Eris here. So those dwarf planets are, by and large, very far away from the sun. Okay, well, we'll talk a little bit about Mars, but doesn't get much snow, but we'll talk. Alright, so we are leaving Earth, and the first stop will be the sun. Sun is very, very important. Along our way, though, we'll notice as we're traveling to the sun, that the planets that we see, they're not stationary. We saw that diagram there, but the planets are in constant motion. You'll notice that the planets that are closest to the sun orbit more quickly than those that are further away. Okay? Which did we say was the closest planet to the sun? Oh, Mercury, very good. Alright, so you see Mercury right there, closest to the sun and going around faster than all the other planets. Yeah. The furthest planet is Neptune, and it's taking its cool time from there.
Question.
Okay, yes, so the question, and you actually answered your own question, because it's asked whether or not the reason the planets that are further away from the sun are outside, well, they're orbiting more slowly, is if it's because they're outside of the sun's gravitational pull. Well, it's not so much that they're completely free of the sun's gravity, otherwise they will float off into space, but they are less tightly bound by gravity to the sun. So they do take a little longer to orbit the sun, and to say that if they were to orbit Neptune or Venus furthest and slowest, if they were to orbit any more quickly, they may pull away from the sun altogether, right? Yes.
How far man get now?
How far? We've actually sent probes as far as Pluto, which is actually the furthest, the furthest that we have been. And beyond that, you're now hoping to go outside of the solar system. We have probes that have gone outside of the solar system, but they haven't discovered anything
You
over
bring
there.
back nothing yet.
Alright. So, we said we were traveling to the sun. And the sun, understand the sun is a star. Just like all the other points of light that you see in the night sky, all those stars, the sun is an example of one, but it happens to be the closest star to us. So that's why it appears so big in the sky, so bright, and gives us so much heat.
So what does star look like? X?
Okay, whenever you look at anything actually, anything at all, what you look at it with, or look to see it, has...
No, I mean if you just say that you look at stars and look at X.
So that is...
What you still look those.
Right, so that is the light from because the star is very, very far away. Very far away. And it's a tiny little point of light. And the light from that star is passing through the atmosphere and is being distorted a bit. It's then going into your eye and being distorted a little bit more, so then you get it, it twinkles. It then doesn't look like that point of light anymore. It's like the light comes a little bit distorted. So then it is not that point. Whereas the sun being much closer, you get to see it as that pretty big circle in the sky.
If the sun is hot, how is space get cold?
Right, so the sun is hot, very, very hot. The reason why we don't, in fact, here on Earth, we do not feel the full heat that the sun is giving off for two reasons. We're at a good distance from the sun still. We're nearly, actually, we're 150 million kilometers away from the sun. So that's far. But that said, the atmosphere around Earth, not only does it provide us with air to breathe, but it regulates the temperature. If we did not have an atmosphere around Earth, the sunny side of Earth would reach temperatures of around 200 degrees Celsius. Really, really hot. And then the shadow side, whenever night fell, the temperature will fall to minus 150 degrees Celsius. Too cold. And that is exactly the conditions that exist on the moon, where there's no atmosphere. Things get really, really hot during the day, and really, really cold at night.
So how does the desert get so hot and we can get that hot?
How does the desert get so hot? Well, climates in desert areas is very different. Desert areas have vast land masses that are, well, when the sun rises, the sun just beats down on that open land. Notice there are no trees, no lakes, no rivers, that also help to regulate temperature. You just have sunlight building up on land mass. It's very hot. But nowhere near the 200 degrees Celsius I just mentioned though. The hottest place on Earth, temperature recorded there was around 58 degrees Celsius. Hot, but nowhere near as hot as 200 degrees. Okay, who wants to go first? You go first?
as the sun is a circle, when we look at it, it only shows waves. It don't really shows the sun, but most people think that most people think it's heaven that we see when we look at the waves.
Okay, so not that I encourage you to look at the sun, but keep in mind, it's never a good idea to stare at the sun, you can damage your eyes. But when we see the sun setting, for example, and when there's a lot of haze around, notice you can actually see that ball of light. What is the sun? Near the horizon. But it looks like a circle. It looks like a ball. I'm not sure what you're referring to, but yes.
No, most people say that is good, like Jesus or heaven.
Okay, well, I have not seen that yet, personally, but
In the
I
moon.
can't describe what other people may have seen
In
when
the
they looked at the sun.
In the moon, yes.
Okay, the moon.
In the moon. You
Oh,
see
that's
Jesus
it.
and baby and
Okay,
Mary.
the markings on the moon, yeah, yes.
Yes. In the moon.
That's a fair statement.
So that means Pluto over 400 degrees.
Oh, Pluto, no, Pluto is so far away. We'll get to Pluto though.
Temperature.
We'll get to
Mercury.
Oh, Mercury. Yes, but we'll get to Mercury too, don't worry. We want to touch, well, make sure we have the important information about the sun. It's a big ball of gas, we cannot stand on it. It's not only because it's really, really hot, but the ball of gas, there's nothing solid about it. Sheer gravity keeps it as big and as massive as this and compresses it, and it, at its center, it generates a lot of energy. It's right at the core of the sun that nuclear process happens. I think a constant nuclear explosion going off all the time, generate a lot of light and a lot of heat. And that is why even at a distance of 150 million kilometers, it's still warm enough for us to be comfortable. And why some planets closer to us actually bake in that heat. The surface temperature of the sun is 5,600 degrees Celsius. But at the core, the very center of the sun, it is in excess of 15 million degrees Celsius.
But as time I go on, we had a know forever. The sun got me real hot. And after the whole like AC, and I know the whole of the AC. The sun real hot.
Okay. All right, so
It should be warm.
it probably will warm up eventually. All right, so and the key thing I want to add is that the sun's gravity. The sun's gravity holds every object in the solar system in orbit around it. Every object you saw in the chart before is held in orbit around the sun by the gravity of the sun alone. And the sun is so big, if you were to put every other planet, for every planet, all the asteroids, all the comets, etc., combine them all, they would still be less than, well, 1/90th the size of, on the mass of the sun. Really, really minuscule compared to the mass of the sun. Question?
What if you turn a spaceship to the sun and try to get a piece of it? Will the gas fit away the container?
That's actually a very good question. So we have sent probes, and right now there is a spaceship launched from Earth orbiting the sun, the Parker Solar Probe. It gets close enough to fly through these wispier areas just above the surface of the sun. They're sampling it, not to say that they can collect material because it's still just, small plasma. But what they're doing, they're measuring certain properties. So you can tell how hot it is, how dense the plasma is, and what chemicals may exist in the plasma. If we ever tried to sample it, I guess it should be possible to collect some of that material, but that mission is not about that. It is possible, but we haven't done it yet. So it's just to say, just keep in mind, we do actually have a space probe that's orbiting, so we've had a lot of questions. This is the last one for a bit, right? Okay, go ahead.
But if we rocket ships going to the sun, most of the time we rocket ships are mostly red. Because
Rocket
of the
ships
heat.
going to the sun, the heat of the sun would destroy normal things. If you were to drive your car, you wouldn't get very close to the sun at all. But rocket ships that are designed to get close to the sun, resist all of the heat and radiation that is emitted by the sun. They're actually designed to get that close and survive the trip.
So that means that after the center and still go over it.
Well, we don't have anything, there's nothing that we can design that can get to the center of the sun. Temperature is too high, the pressure, there's a lot of pressure within the sun that we haven't designed anything that can
So
survive.
only from your opinion, as the rocket ship goes straight in the middle of the sun, will it break?
Yes.
That's correct.
All right, so we're gonna leave the sun.
Excuse me,
Oh.
before you leave, what kind of star is the sun?
The sun is a yellow dwarf star. It's a G2V type star, but if this yellow dwarf star, you can work with that. So that also means that it's not the biggest star. Compared to others, it's a dwarf, relatively small. There's a lot to be said about stars. The fact that it's so relatively small, it'll have a very long lifespan. Stars much bigger and have much shorter lifespan. Other stars are located outside of the solar system, but we'll get to that. We'll get to that. Does anyone remember where the first stop will be? We're coming from the sun now, heading out. The first planet we're going to come to is what? Mercury. Good. So, Mercury, closest planet to the sun, is also the smallest of the planets. It orbits the sun every 88 days. Well, does anyone know how long it takes Earth to orbit the sun? Go ahead.
365 days.
Very good, 265 days. So what we're saying is that a year on Mercury lasts only 88 days. Very, very good. So there's no air on Mercury, no water. And it's very, very hot on the surface, 430 degrees Celsius.
Burn.
Yep, we would not survive here. We would not survive.
So I think that's the idea for one. We will make.
You will start
Yep.
along.
Turn it action. Basically, for two of us. Alright, so we're gonna skip. We're gonna leave Mercury now. Does anyone know what the next stop will be? Venus, because on the ball, beautiful. So Venus is roughly the same size as Earth. Roughly the same size. And actually has an atmosphere, really thick, but it's comprised mostly of carbon dioxide. Can we breathe carbon dioxide? No. Why? We're trying to. And it is actually the hottest planet. Notice that Mercury is closer to the sun, but it's not as hot as Venus. The reason is because that really thick atmosphere is like a really warm blanket. You're wearing a really warm blanket really close to the sun. So you're trapping the heat from the sun underneath that blanket. So you're making yourself that much hotter. And that is what is happening on Venus. There's no water and the clouds contain sulfuric acid, which means, well, we have not been very successful at sending spacecraft to Venus. The things that we have sent, they don't last very long. The heat causes them to melt, and the acid in the atmosphere erodes and causes them to disintegrate. It's way up there.
Maybe not rockets from Earth.
If we do it well, no, we do not currently launch anything from Barbados, but there was a time when we had a HARP project, a high altitude research project. We were firing projectiles from a huge cannon near Paragon. The remnants of it is still there. If you ever go on a field trip to the south coast of Barbados, make sure to visit the HARP den. It's near Paragon. It's still there. But it's a memory of a time, remember the time when we used to launch projectiles almost to space. We used to land back in the ocean 50 odd miles just to the southeast of Barbados. But yeah, we were really close to having a space program. Really, really close. What's that? Venus? It has an atmosphere, it has air, but nothing that we can breathe, right? The gases within it poisonous to us. So again, another planet that is not safe for us to be on.
So if you are successful, that's not aircraft that you're just going to know. Will you have permission to send aircraft?
Or the projectile? Well, that's a question that our government might be able to answer. Yeah, so, right, I would say that in many places, well, just south of Barbados, French Guyana, there is a huge launch facility. Rockets launch from there very often. Being close to the equator, like we are, Barbados is just 13 degrees north of the equator. Being close to the equator is advantageous. It allows us to relatively easily launch projectiles into space. There's concepts there related to physics and math that you'll learn about when you get older, but it's just to say that maybe in the future we might have a real space program in Barbados. We're going to leave Venus. Where to next? Where do you think?
Jupiter.
No. Are we going to skip, just to say, we're going to skip past Earth. Just to be clear, we started at Earth, so we're going to skip past Earth. Where to next? No. I heard it. Mars. Very good. So, Mars is up next. So that too has an atmosphere that is really thin now, so really thin. And again, carbon dioxide. So it's nothing for us to survive. It has ice caps, if you look here. It has South Polar ice cap and North Polar ice cap. It also has clouds in its atmosphere, but again, just carbon dioxide. Cannot breathe it. There's no water. And notice the red color. The red color is actually from iron oxide. Iron oxide here on Earth, we recognize it as rust. In the surface of Mars is a lot of rust, and that gives it that reddish color. Notice the average temperature, minus 85 degrees Celsius. Can we survive at minus 85 degrees Celsius? No, too cold. All right. So a series of hands. I'll start with Mars.
So, sir, if on Earth all the land starts to die out, we would have moved to Mars, but since Mars don't have like the air that we could breathe in, the whole population of humans would die out.
Very good insights there. So the whole notion of us abandoning Earth at some point because it becomes a planet that we cannot survive on anymore, and then going to another planet like Mars, understand that Mars by default, well, right, it's very difficult for us as human beings to survive on Mars as it is. And trying to create an environment for us to survive on it, right now it's certainly impossible. It's not really feasible or possible, right? So, yes, all the reason why, all the more reason why we need to take care of this planet. It's the only one that's survives us.
I have nowhere to go.
You know, we should not really entertain the thought of seeing any other places, a place that we can go, because based on all the science we know, there are no other places that life survives on.
So you can, when you're in snow, like cold areas, and you know, like result some like stuff when you're in snow, and it's like feeling like a carbon dioxide, so when you bring it over, like it's freezing your face.
Okay, so you mean on Mars, if that would happen? Well, yes, at minus 85 degrees, if you did try to breathe out anything, yeah, it would definitely, and it's more the moisture in your breath that freezes up, so you get that condensation that forms those clouds. So yes, certainly.
So, even if you could only manage to live on Mars, how in the world will get food? And water is already a big problem, so you'll have to make it so that other creatures can live on Mars as well.
Exactly. So, very good point being made here. It can't be just us surviving. In order for us, we know we depend, as human beings, depend on food. We eat fish and other chicken and meats and stuff, and all of that really and truly must find a way for it to survive wherever you go. It can't be us trying to live off of liquid chemicals that we probably won't survive very long at all. So we need to have the things that allow us to survive with us as well. Right? So we know it's more than just us. Right?
Why is it too, we're able to get a rocket that can clean up the
A rocket to clean off the rust? Well, what color would it be? If we clean off all of the rust, it might be a grayish color with some of these other dark markings, and then like these ice caps will remain. So think of the moon. with some ice caps, because the moon itself has mostly gray with darker areas of the, well, add to that some ice caps. Yeah.
So those black marks are like birthmarks, right?
Not like
Black marks are like birthmarks.
birthmarks.
The earth.
No, those are just areas where you have different compounds in the soil and surface. So you have, again, mostly that iron oxide here, but then you've got some other chemicals and stuff that actually have different color also present. All right, so one last question. Okay,
Jonathan?
no, that's okay. No, go ahead.
We made something as big as the sun, and we did out of planet Earth, and we stocked enough water and food. How long was it take for we to live in the space?
All right, so that's a very complex question. If we do things properly, we may live very, very long. But again, we are not absolutely sure what we would absolutely need to survive, you know, once we leave Earth. It's easy to think that, you know, when you're here on Earth, when you go to a different country, you generally will find the things you need to survive. Just going from continent to continent, there will always be things you need to survive. But as soon as you leave this planet, there's no guarantee that you'll have the things needed. If you try to take everything that you think you might need, if you forget one thing, that is it. All right, so we are going to leave Mars.
Excuse me. I had my hand up, I was waiting.
Oh, sorry.
Yes, it's okay. Has its in atmosphere. And then it has ice caps at the north and the south. So the ice caps remain ice all year.
Actually, Mars has seasons like Earth.
And they don't melt and
They
they
don't, right, well, okay, so the carbon dioxide, there's just enough atmospheric pressure to keep the carbon dioxide frozen.
frozen all the time.
When it heats up, it goes from solid straight to gas. It's like dry ice. You know how we handle dry ice here on Earth? It's frozen, but then it goes straight to gas. So we use that to get these cloud effects on stages when you have performances and stuff.
Oh, okay.
It starts off with a frozen material, but then it goes straight to gas.
Gas.
The same thing happens
Okay.
on Mars.
Okay.
Very good question. So, we're going to leave Mars, but we're going to pass through the asteroid belt. Yeah, sounds like you're ready to go. All right, love it. So, on our way, we're past an asteroid. We'll learn a little bit about it. Asteroids are actually small, relatively small, rocky bodies, irregular in shape, so it's not spherical. And often they suffer impacts from other bodies as well. So we're talking about a piece of rock that could be as small as 1 meter, which is around this size, or this size. So as much as 1,000 kilometers in diameter, right? And most asteroids orbit the sun between Mars and Jupiter. So we're to pass through the asteroid belt and make our way to which planet? Does anyone know which planet is this? Jupiter, very good.
Oh.
We're going very well.
Oh.
So Jupiter, it's the largest planet in the solar
glad they're
system,
coming down
much
to
bigger
Earth.
than Earth, 11 times wider than Earth is. It has storms, and clouds, and this feature here, the Great Red Spot, which has actually been around for.
Oh, I know the great red spot is Jupiter.
And that's actually a huge
Okay, good. Yes, it's been around for hundreds of years.
It's sometimes called the great red spot.
It's actually a storm. Interestingly enough, it's not like a hurricane first. Well, in essence, you have high winds, etc., etc. But whereas hurricanes are cyclones where the winds are pulled in towards the center, Great Red Spot actually winds go from the center outwards. It's actually a high pressure system. Still very strong winds. Jupiter rotates once every 10 hours, give or take. So, how long does it take for Earth to rotate?
1 year.
Earth to rotate, come on, look at this.
27 days.
No. Turn once on its axis. How long does it take Earth to turn once?
Like,
One day, 24 hours.
for Earth to rotate.
So what we're saying is that, 24 hours Earth to rotate, that's the length of a day. So we're saying that a day on Jupiter is just 10 hours long.
Mm.
Okay? So the days go by really quick. That's half the time, that's not half the time that we do here on Earth. That's the question. So Jupiter is all gas, mostly hydrogen and helium. So there's no hole to be made per se. It'll just pass straight through, and the gases might be separated for a fraction of a second, then because it's all gas. Whatever you send there will just pass straight through that characteristic center. You could try. It'll go pretty deep down, but within Jupiter itself, again, it's a big gas ball, and similar to the sun, the gravity of Jupiter is such that as you get closer to the center, the gravity causes the areas near the center to be much warmer. Pretty hot indeed at some point, and then the atmospheric pressure, the overall pressure that you'll feel as you get back goes in towards the center, gets really, really high, and then that graph will probably disintegrate before it gets to the center. Yeah? Okay, any questions? Any other questions?